Let us do a very simple and a very interesting sum. Let's see the sum. This is a sum where we have the figure given and we have some information. Let's understand the information. It says that in triangle PQR, segment PM is a median. So we have segment PM as a median. That means M is a midpoint. So we have QM and M are equal. Bisectors of angle PMQ and angle PMR. So for angle PMQ, we have a bisector that is MX. And for angle PMR, we have a bisector that is MY. They intersect at sides PQ at X and PR at Y respectively. That's given. It says further, prove that segment XY is parallel to side QR. Now let's understand. We want XY parallel to QR. That means we are saying that we want a line parallel to a side in a triangle. When will that happen? You're very correct. If the ratios to be equal. Which ratios? We should get PX upon XQ equal to PY upon YR. We want these ratios to be equal. That's the hint, right? Now, how do we get that? No, this is very easy because this is a form of an activity. And activity is very easy because you have to just fill in the boxes there. It's very simple. Right, now let's look at the entire figure. We want two ratios. Let's look at the first ratio which we want. We want PX upon XQ. We want PX upon XQ. Look at the triangle which I am showing you right now. Only focus on this triangle. Now in this triangle PMQ, what is MX? It's a bisector of angle PMQ. And if it is a bisector, we can use the property of angle bisector of a triangle. So let's use that. So now we can write in triangle PMQ, which we have there, MX bisects angle PMQ. So we get the two ratios equal here. What is that? We get MP upon MQ is equal to PX upon XQ, and that is what we write in the boxes there. And that's our result number 1. And the reason is very simple, property of angle bisector of a triangle. Was that easy? Yes. And because of this, we got the first ratio which we wanted, PX upon XQ. See there, that's the right hand side. Let's look. We want PY upon YR, and in order to get that, we're going to consider the other triangle. Now you're very correct. Now you can do this very fast, right? So now we're going to say in triangle PMR, ray MY bisects angle PMR, right? So we get the two ratios equal. What is that? We get MP upon MR is equal to PY upon YR, and that is what we write there. And that's our result number 2, isn't it? Very, very easy, right? Beautiful. So what has happened is the second ratio which we wanted, PY upon VR, got it. The first ratio we got in result number 1 on the right hand side. The second ratio we got in result number 2 on the right hand side. But we want this right hand sides to be equal. Now tell me, when will the right hand sides be equal? The right hand sides will be equal if we get the left hand sides to be equal. Now look on the left hand side. If you look at this left hand side, it is MP upon MQ. And here it is MP upon MR. Look at the numerator, MP, MP. They are equal. Look at the denominator. If we get the denominator equal, we'll get the ratios equal, right? Look at the denominator. Here it is MQ, here it is MR. What can we say about MQ and MR? You know, they are equal. Why? Because PM is a median. And if PM is a median, that means M is a midpoint. And if M is a midpoint, we are saying that MQ is equal to MR. That means we are getting those denominators equal. And if those denominators are equal, that means we are saying that this ratio MP upon MQ and this ratio MP upon MR, they are equal, right? But why are they equal? You got it from 1, 2, and because M is a midpoint of QR, isn't it? Now we got this. Now once we get this, if the left hand sides are equal, can we write the right hand sides equal? That is what we are going to write. Left hand sides are equal. We got it here. That means we are saying that the right hand sides are also equal. And that is what we are writing. These right hand sides are equal. So we got PX upon XQ is equal to PY upon YR. We got this. And if we get this ratios equal, as they have written there, we can write that XY is parallel to QR. And the reason is, as written there, converse of basic proportionality theorem. Wasn't that easy? Beautiful. Very easy, right?